Now arsenic is As. Okay, that's 33 and 75. This is arsenic. So we've got arsenic. Which group is it in? It has 5 valence electrons. How many bonds would it make? Is it a metal or a non-metal?
3.
So it's going to make 3 bonds, right? And is it a metal or a non-metal?
It's a non-metal.
Non-metal.
It's a non-metal because it's in group 5. So that's a non-metal. And non-metals, they form. I said, who is it bonding with? He's saying draw a diagram with fluorine. It's bonding with fluorine. He's already told us that it's going to form covalent compounds. Now fluorine makes just 1 bond. Arsenic would make 3 bonds. So arsenic would be surrounded by 3 fluorine atoms, right?
Yes, sir.
So there would be 3 single bonds, right? If you draw the structural formula, it's going to be arsenic making 3 bonds with 3 fluorine atoms, and that's it. So that's the bonding is complete. You've shown the bonding, but the dot and cross diagram is still incomplete because you have to draw the non-bonding electrons, the ones that are not involved in bonding. And the easy way to figure that out is that each atom should have a total of 8 electrons around it. So how many electrons are left for arsenic? They should be
Sir, 2.
2 more electrons because you already have 6 electrons. Now,
Yes, sir.
to complete the 8 electrons, there should be 2 electrons, and that makes sense because it had 5 electrons, 1 shared over here, 1 shared over here, 1 shared over here, and you're left with 2. But the easy way is just count the electrons, and the total number of electrons should be 8. Except for hydrogen. Hydrogen can only have a maximum of 2 electrons. So fluorine has 6 non-bonding electrons. This fluorine would also have a total of, and this one would also have a total of 6.
सर इसमें तीसरे शेल में लिखा हुआ 18 इलेक्ट्रॉन्स है.
हाँ,
तो फिर 18 इलेक्ट्रॉन कैसे हो गए, हालांकि एक तो शेल 8 इलेक्ट्रॉन ले सकता है.
नहीं, ये बहुत पहले ना, right in the beginning we had discussed. This one is about chemical bonding, right? Where's the very early on, बल्कि इधर end पे ना, I'll just recap this. And what we had discussed was so I'm just going to explain this very, very quickly. Remember that that the first shell number 1, can have a maximum of 2 electrons. Also, shell number 2 can have a maximum of 8 electrons, and shell number 3 can have a maximum of 18 electrons. Shell number 4 can have a maximum of 32 electrons. 5 can have a maximum of 50 electrons because the shells are becoming bigger, and the formula is 2n squared. If you keep on increasing the number of shells, the number of electrons also keeps on increasing. You get bigger and bigger shells. ठीक है, Fan, is this clear?
यस सर. सर वो डबल हो रहा है.
नहीं, not doubling. Size बढ़ रहा है ना, ठीक है, इनका size, it's in.
Okay.
So the shells are becoming bigger, right? So you have, first shell is very small, so it can't accommodate a lot of electrons, but the second is bigger and the third is even bigger. तो एक तो ये याद रखना कि the 8 electron, वो जो 8 electron वाली बात है ना, that only is true up till the second shell. Clear?
यस सर.
And
तो फिर हम जब कंप्लीट ऑक्टेट बोलते हैं तो इसका मतलब कि उसके 8 इलेक्ट्रॉन्स हैं और वो कंप्लीट है.
हाँ, ठीक है.
ओके सर.
अच्छा, but the point is कि like in जिसके थर्ड shells होते हैं ना, अच्छा, who has only one shell, the first period? First period के the maximum electrons कितने होते हैं? There's just 2. You can't have more than 2 electrons. ठीक है, हाइड्रोजन के कभी 8 electrons नहीं होते. Second period के maximum electrons कितने, मतलब shells कितने होते हैं? That's 2. So that means its outer shell can have a maximum of 8 electrons. Third period में जो element होते हैं, they have the outer shell, they have 3 shells. So they can have a maximum of 18 electrons. Is this clear?
यस सर.
So the thing is अच्छा, तो हम ये 8 क्यों पढ़ते हैं बार बार? Because these are the elements that are more abundant. Period 2 elements are way more abundant. Oxygen, nitrogen, etc. These are the ones that you see every day. So, and period 3 में भी ना, most of the time they just fill 8 electrons. They don't complete the outer shell fully, but they can accommodate 18 electrons because it's a bigger shell. So remember that. So which is why ये जो arsenic है ना, look at arsenic over here. It's in what period? It's in the fourth period. The fourth period के अंदर ना, fourth shell के अंदर ना, maximum electrons जो आएंगे, that would be 32. So if you go back and have a look at arsenic over here, where did it go? Just a second. If you go and have a look at arsenic, this shell can have a maximum of 32 electrons. Is that clear?
Yes, sir.
So, but you don't have to worry about, but just don't get confused with 18. Is that clear?
Yes, sir.
So now, so this is arsenic fluoride. Let's move to the next one. You've got table gives the melting points, the boiling points, and the electrical properties of 6 substances. Which 2 substances could be metals? In Sarame, which one is metals? Anyone? Adil? Turan?
Sir, E and F.
Metals. So number 1, metals की differentiating property. How did you figure out that E and F?
सर तो उनका मेल्टिंग एंड बॉइलिंग पॉइंट ज़्यादा है.
Nee, remember, metals don't always have. Can't get metals. This was metals, right? So remember the properties of metals. I said that metals do have high melting and boiling points, but not really high melting. Transition metals have really high melting points, okay? Like the one that's shown over here. ये याद रखना, ठीक है? Be very careful. कि these are very high melting points. So transition metals can have really high melting points, like iron and ये जो बीच में नहीं आ रहे, these ones over here. Gold.
Yes, sir.
They can have very high melting points. But group 1 metals actually have really low melting points. They melt at 100 degrees centigrade, which is below 100 actually. Some even melt at 37. Okay, for example, you've got francium. उसका एक सेकंड melting point गूगल कर लेते हैं. अच्छा, francium का देखो melting point, that's 8 degrees centigrade. यानी it's going to be liquid at room temperature. Do you get my point? So remember,
Yes, sir.
when we say that metals have high melting points, that's not always true because there's a lot of exceptions. And there's a lot of exceptions, and exception like mercury, and I can add more exceptions to it. I mean, we can add francium as well. Right? We just did that. So the point is, having high melting points and boiling points, that most of the metals, they do have high melting and boiling points, but not all of them. Okay, let me just also, we did this. So the general trend is that they do have high melting points, but not all of them. These are ionic lattices and ionic compounds. They all have high melting points. You pick any one, they're going to have ionic compounds. They always have, like you pick you pick NaCl, melting point, and it's going to be 801 degrees centigrade. So that's pretty high. You pick MgO, and MgO, where's the melting point? It's 3,250. So that's really high. It's a very high melting point. So the point is, these ionic compounds always have high melting points. Metals, not always. Is that clear?
जी सर.
So Mirza, what's the
Yes,
differentiating?
sir.
So how would you identify a metal? Like based on what property? You can't use high melting points. क्योंकि if they gave you mercury, you can't really. That has a very low melting point. It's minus 37 or something. So what's the differentiating property of a metal? That it conducts electricity in all states, and it's a very good conductor of heat as well, due to the free moving electrons in the lattice. And another very differentiating property of a metal is that it's malleable and ductile. So if you want to identify a metal, so now tell me which one is a metal. Don't go for the melting and boiling points.
Sir,
C and
C
F.
and F.
Which one? F and
C.
so you got C and F, right? So those are your metals. Which substance is nitrogen? Nitrogen is a diatomic gas. It's N2. It's a covalent molecule. There are two nitrogen atoms. Nitrogen makes it's in group 5, so it makes 3 bonds. So covalent molecules, what properties would they have? Low melting points or high melting
सर जब
points?
कोवेलेंट बॉन्ड बनता है तो नाइट्रेट नहीं हो जाएगा वो, नाइट्राइड?
नहीं.
ओके सर.
But nitride, I'll tell you what nitride is. What you're referring to is this thing. You're talking about, one second. So you're talking about ionic compounds. Where's ionic compounds? Ionic compounds में I told you कि ये जो नॉन मेटल होता है ना उसका नाम चेंज हो जाता है. If it's oxygen and it forms a negative ion, it becomes oxide. ठीक है. मतलब ये जो होगा ना सोडियम
ओके सर. यस सर.
और तो that happens in ionic compounds. ठीक है.
ओके सर.
Calcium and chloride, magnesium, sulfur की वजह sulfide. So that happens in ionic compounds, not in covalent. Achha, what were covalent compound properties?
They don't conduct electricity.
Okay, so they never. That's one way differentiating property, that they never conduct electricity. So which one is a covalent compound? Does not conduct. Does not conduct. So that is a covalent compound, right? The first one. And then you have this as well. Okay, does not conduct. Does not conduct, right? So that's also a covalent compound. And this one is also a covalent compound. So the question now is, so you figure out covalent compounds, right? It's a covalent molecule. So figure out 3 of them. अब मुझे बताओ, just hold on 1 minute, अजान हो जाए, ठीक है? Just wait 1 minute. So now tell me, so now tell me, can you hear me? Now tell me which one. You've got 3,
यस सर.
you've identified 3 covalent molecules, right? So covalent molecules, do they have low melting points or high melting points?
सर लो मेल्टिंग पॉइंट.
Acha, so A and D, they both have low melting points, right?
यस सर.
E actually has very high melting points, so that must be a giant covalent structure. That must be, where's the giant covalent structure? That might be diamond graphite, or I mean these two. So it might be a giant covalent structure like diamond or graphite. So they've got low melting points, right? So we can ignore E. And how do you figure out? So we can get rid of E, because that's a giant covalent structure. It's a covalent molecule, but it's not a molecule. It's a giant covalent structure like diamond and graphite. So out of A and D, these two, how would you figure out which one is nitrogen? अब मुझे तो nitrogen की state क्या होती है room temperature पे? What is the state of nitrogen at 25? It's a like you have nitrogen gas around you.
जी सर गैस के फॉर्म में होता है वो
ठीक है, so it's in the form of a gas, right? So let's focus on D first. At 25 degrees centigrade, remember melting points in niche, that's a solid. Between the melting and boiling point, that's a liquid, and above the boiling point, that's a gas. So this is liquid. This अगर यहाँ पे temperature, that's a gas. Over here, it's a solid. अब मुझे explain करो 25 डिग्री सेंटीग्रेड बीच में आता है, इधर आता है, इधर आता है. Where does it come?
सर सॉलिड
नहीं, 25 डिग्री सेंटीग्रेड बीच में आता है
ओह
exactly.
सॉरी लिक्विड यस सर यस
ठीक है, तो इसका मतलब है इट्स नॉट गोइंग टू बी डी, क्योंकि रूम टेम्परेचर पे डी जो है ना, दैट्स अ लिक्विड. अच्छा इधर बताओ, ए के अंदर 25 डिग्री सेंटीग्रेड कहाँ पे आता है? बीच में आएगा तो लिक्विड आएगा. अगर वो बॉइलिंग पॉइंट से ज़्यादा टेम्परेचर है तो इट्स गोइंग टू बी अ गैस, और उससे कम टेम्परेचर होगा मेल्टिंग पॉइंट से, इट्स गोइंग टू बी अ सॉलिड. तो 25 कहाँ पे होगा? 25 यहाँ पे होगा ना, इट्स गोइंग टू बी मच हायर देन इट्स बॉइलिंग पॉइंट. क्लियर है?
यस सर
इसका मतलब है the answer for this is going to be A. Is this clear to everyone? Salim, is this clear?
Yes.
ठीक है.
Yes, sir.
So, अच्छा next one is which substance is an ionic solid? Ionic substances, do they conduct electricity?
In
यस
solution.
सर बट व्हेन मोल्टन और इन एक्वा स्टेट
ठीक है, so in solution exactly. ठीक है.
यस
So
सर
when it's molten, because solid state में the ions they cannot
मूव
move. ठीक है, ये बना हुआ है. तो solid state में the positive and the negative ions are all stuck in their place. So it's a giant ionic lattice. क्या और क्या properties होती है melting points? Are they high or low?
हाई
ठीक है, they're kind of really high because there's strong forces of attraction between positive and negative ions. And another property is that they're brittle. You can't alter the lattice. You can't hammer it, because if you hammer it, it's very sensitive to it. Because if you hammer it and two positive ions they get together, they would repel each other, जिसकी वजह से cracks पड़ जाएंगे. It would start cracking up. So in this case, which one is the compound that's ionic? ये सारा रब करें. कौन? Anyone? Which one is ionic?
B, I said B.
अच्छा B. ठीक है. Solid के अंदर it's not going to conduct, और उसके अलावा it's going to be a good conductor, and it's going to have high melting points. Ionic compounds, they always have high melting points. और कोई है? नहीं, और कोई भी नहीं है ना? Yep, that's the only option, B.
यस सर
अच्छा, which substance is a liquid at room temperature? वो तो भी किया था हमने. ये D था ना, जिसका room temperature 25 डिग्री सेंटीग्रेड बीच में आ रहा था.
जी सर यस सर
So that's going to be D. अच्छा, which substance has a giant covalent structure similar to that of diamond? I told you it's covalent के अंदर there is no electric conduction, and diamond has very high melting points.
यस सर ई
So it's similar to diamond. ठीक है, so it's going to have high melting points, boiling points. Which two substances could exist as simple covalent molecules? तो वो जो does not conduct ये हमने किया था. First one was a simple covalent molecule, low melting points, no electric conduction. इसकी भी low melting points and there is no electric conduction.
यस सर नो ए एंड डी
So it's A and D.
सर
अच्छा, next is equations को छोड़ देते हैं. ये फिर से it's arsenic and hydrogen, we can ignore that. Explain the phrase zinc alloy. It's whenever you have an alloy, you can write physical. It's a physical mixture of zinc metal with another metal. दो दफा
सर बहुत सारे मेटल्स नहीं हो सकते
बहुत सारे भी हो सकते हैं.
ओके
अच्छा alloys it's अच्छा alloys and pure metals में what's the difference? What's the one major difference between alloys and pure metals properties में?
So alloys are light.
नहीं, alloys are not light, not necessarily. Aluminium is very light. Aluminium is a pure metal. You make planes out of aluminium, ठीक है, because it's so light. Uh, so one major difference between metals and alloys are kind of exactly the same. What's the one major difference between
You said they have different sized ions.
ठीक है, so what effect does that have on the property of the metal? Like where did we do alloys? This was a pure metal, right? Pure metal,
Yes, sir.
the lattice was very regular. They were all metal atoms. They like to lose electrons, that they all became ions, positive ions, and the electrons are just roaming around, right? So that's a pure metal, and because the ions were regularly arranged, you hammer it and you can the ions can sort of slip and slide, right? But when it comes to an alloy, what happens is it's a mixture of metals. So it's exactly the same structure except for one difference, that now the atoms have different sizes. Like if you add copper and zinc, the copper atom would have a different size. It's going to have a different number of shells. The zinc atom would have a different number of shells. So the lattice would become kind of irregular. Now they're no longer neatly shaped, regularly arranged. So when you apply a force, the ions cannot, because they're so irregularly arranged, they can't really slip and slide. Is that clear? So the
Yes, sir.
one major difference वो यहाँ पे लिखा हुआ भी है, one major difference is that alloys are stronger and they're less malleable and ductile. You can't easily reshape them, which is why you make everything out of alloys, because they're kind of really strong. Pure metals are kind of really soft. ठीक है, is that clear?
Yes, sir.
And I'm just going to highlight this again. This is the main major difference between metals. That's the major difference between the properties. All the properties are the same except for this one, that alloys are stronger. So, and more impurities added, more stronger it's going to become. It's going to become even stronger and less flexible, so that it would become brittle. Actually, like uh, if you have gardening tools, they are brittle, which means that they're not going to bend because they're going to be very inflexible. The ions cannot slip and slide. If you apply too much force, they're going to break. Uh, Pure metals don't break. They stretch, they deform, they get D-shaped because the ions can slip and slide. As anyways, coming back to this, that's the major difference. So he's saying one other large-scale use of zinc. We can ignore this. We haven't done that. Describe the bonding in a typical metal such as zinc, and then explain why it is malleable. You may use a diagram to illustrate your answer. Now, whenever you're being asked to draw a diagram of a metal, every time you're going to draw this thing, you're just going to simply draw this. That's it. And make sure try and draw it neatly. You don't have to draw so many. Just make a row of three. The width, there should be 3 ions on the horizontal axis, 3 ions on the vertical axis. That's it. So it's 9 atoms. At least draw 9 atoms, and there would be a bunch of electrons roaming around. The ions should be close together. I mean, they should be close together, not very far apart. People draw really bad diagrams. So make sure it kind of looks similar to this. And the description that you're going to write is, where's the description? Malleable and ductile. You're going to write the description that positive ions in the giant metallic lattice slip and slide when a force is applied. That's your description. That's why they're malleable and ductile. They can easily, when you apply a force, the ions can slip and slide. So that is what you're going to write in the answer. And you also have to describe the bonding in a typical metal. So you've drawn a structure. So the bonding could be described in this way, that it's a lattice of positive metal ions and a sea of free moving electrons. And the negatively charged electrons attract the positive metal ions. The electrons are in the middle. They're acting as a glue. They're negatively charged. They attract the positive ions. The positive ions attract the electrons. So they're all mutually attracted to each other. So that's how you're going to describe this. Now the next, where's the worksheet? I said, suggest why the introduction of a different atom into the structure makes the alloy less malleable than pure metal. So what's the explanation for that? You add,
So there are small or big ions in between the normal ions.
okay, so what you're going to write is that different sized ions, they create an irregular metallic lattice. And it becomes difficult for ions to slip and slide. Hence, they become less malleable and ductile. Is that clear?
Yes, sir.
So that is what is this clear to everyone, right?
Yes.
Ji, sir.
So remember about metals. Just use these notes. These are all answers to certain things. Like why alloy is strong, you write this. Okay, if you add more impurities, it becomes even stronger. It becomes more irregularly arranged. So all the answers are given over here. Now the next one, I said this one. They're asking you to draw the dot and cross diagram for a methanol molecule. Now obviously you don't know methanol yet, but I'm going to write the formula of methanol, which is CH3OH. So it is it covalent or ionic or what?
Sir, covalent.
I say if you've got carbon is a non-metal, hydrogen is a non-metal, oxygen is a non-metal. All of them are non-metal, so it's covalent. Carbon is in group 4. How many bonds does it make?
4.
So it's going to make 4 bonds, right? So you've got 3 hydrogens. There's an oxygen and there's another hydrogen, right? So carbon makes 4 bonds. Oxygen is in group 6. Group 6 makes
2 bonds.
Okay, so that's done. Carbon makes 4 bonds. Oxygen makes 2 bonds. Hydrogen makes 1 bond, so that's done.
Yeah.
Anyways, you figured out the structural formula. You're being asked to draw the dot and cross diagram, and you have to follow the symbols that they're using. So carbon is in the middle. There's an H, so I'm just going to draw a rough diagram. H, there's an O over here, and there's another H, right? So H. So carbon is cross, and hydrogen is dot. So cross dot, dot cross. Oxygen is the shaded one, so it's going to be, sorry, carbon was cross. And this is carbon with shaded dot. And this would be, oxygen is the shaded dot, and the carbon is the dot, right? Is this clear?
Yes, sir.
And the only thing that you have to do is make sure that all of them have a complete octet, the non-bonding electrons. So oxygen has how many electrons missing? Like how many more non-bonding electrons should I draw? Anyone? कितने बच गए
4.
oxygen? You get 4. So the four in the bonded, so there should be 4 electrons which are non-bonding. Hydrogens are complete. They can only have 2 electrons, so that's done. This is done. This is done. Carbon is also complete. It can have a maximum of 8 electrons, so that's also done. Let's do this one. He's saying identify element C. How do you identify this? How do you identify elements? What do you look for when you try to identify?
So the valence electrons.
So there are actually a couple of ways to identify this. One is which group is it in?
Group 5.
It's in group
Yes.
5. And which period is it in?
period 5.
ठीक है, period is the number of shells, so that's 1, 2, 3, 4, and 5 shells. So it's in period 5 and also in group 5. So this is period 1, period 2, period 3, period 4, period 5, and it's in group 5 as well. So it's antimony, which is SP. So that's one way of identifying. So it's this one is antimony, which is known as SP. The other way is elements are identified according to the number of protons. So you can add them, all of them up, and you can figure out the number of protons. But this was kind of easier. So which element in the list does not form any compound? So in the periodic table, which of the elements don't form compounds?
So group
Group
0.
8.
Group 0 or group 8, depending on the periodic table you're using. So that's noble gases. They don't. So which one do you think is that element over here?
Element B.
Okay, so that's B because its outer shells are already complete. So which element in the list forms a chloride of the type XCl2? Now, so how many? Now they didn't tell you whether it's ionic or covalent, right? So let's assume it's ionic. Cl is in group 7, right? And this element X, let's assume that's metal, right? Metal is group 1 or 2. So when would it, Cl gains how many electrons if it's ionic?
1.
And there are 2 Cls. So that means how many electrons are gained in total? That's 2.
2.
So X must be losing 2 electrons, right? So it must be in group 2, right? Is that clear?
Yes, sir.
Yes, sir.
Yes.
So so it could be element A, right? But it could be element A if it's ionic. But what if it's covalent, right? So that means X must also be a nonmetal, right? So it could be a covalent molecule as well. So now I'm assuming that because they didn't tell me what it was, right? So now I'm assuming it's covalent. Cl makes how many bonds? Just one, right? And
Yes, sir.
you've got X bonded to 2 Cls, right? So which group is X in? Like which non-metal makes 2 bonds? Group 7, group 6, group 5, 4.
Group
Which?
6.
So it's
Yes,
groups.
sir. Group 6.
So it can be element. It can be element D as well, right? So the point is they didn't tell us whether it was ionic or covalent. They didn't tell us that X was a metal or was it a non-metal. If it's a metal, then it's going to be in group 2 and it would lose 2 electrons and therefore you would need 2 Cls so that 2 electrons can be gained. So A, otherwise if it's a covalent molecule, then it's going to be in group 6 and there would be a sharing of electrons and 2 Cls would bond with it. So is this clear?
Yes, sir.
So which 2 elements would react together to form a compound of the type XY4? So X with 4 Ys. So which group is X in?
Group 4.
Okay, so group 4
Yes,
makes,
sir.
so it's in group 4, that's element E. And Y over here is making just one bond. So who makes one bond?
So group 7.
So that is going to be element F. So E and F would react together to form a molecule with this formula X with 4 Ys. Okay, is this clear?
Yes, sir.
Yes.
And so which element, forget this, we didn't do any reaction, so ignore that. अच्छा we are remember the XCl2. I mean, it's a separate question, but it's the same one. Like strontium is in group 2. I think it's in group 2. It's over here. Strontium is in group 2. And sulfur is over here. It's in group 6. So just like I told you previously, that XCl2 can be formed by a substance, X could be a metal or it could be a non-metal. If it's a non-metal, it would form a covalent molecule. It would be in group 6. And if it's a metal, then it would be in group 2. Anyways, which one is ionic, which one is covalent, based on the properties? Like you've got high melting point. So is this ionic or covalent?
Sir, ionic.
Okay. And anyways, that's pretty obvious because it's a metal and a non-metal, right? This one is a covalent molecule, right? Because obviously it's two non-metals. So this one is sulfur sharing electrons with 2 Cls. And this other one is strontium forming a 2 plus ions and Cl forming a minus 1 ions, but obviously you need 2 Cl ions so that the electrons lost and gained are equal. So use the data, explain why sulfur chloride is a liquid at room temperature 25. So why is it a liquid? If the temperature is between the melting and boiling points, so is 25, I mean, you've got minus 120, that's the melting point, and you've got 59 degrees centigrade, that's the boiling point. So 25 would come right in the middle, right? So what you're going to write,
Yes, sir.
what you're going to write is 25 degrees centigrade is higher than the melting point
And lower than the boiling point.
and it's lower than the boiling point. So hence it's a liquid. That's the next one. Strontium is a metal and sulfur is a non-metal. Explain why both have chlorides of the type XCl2. We just have to explain now. So strontium loses 2 electrons while Cl gains 1 electron. Hence, there should be 2 Cl atoms. Two Cl atoms are needed. I said, what about the other one, the covalent? Sulfur shares 2 electrons or makes 2 bonds, while chlorine shares only 1 electron. So sulfur can only share 1 electron with one chlorine. Sulfur will share the other electron with another chlorine. So hence 2 Cl atoms are again needed when they are forming a covalent compound. Okay. Explain the difference in electrical conductivity. Why does liquid strontium chloride conduct electricity? That's the last question. Let's finish this up. Why does strontium chloride conduct electricity when it's liquid?
Because the
Sir, because
electrostatic forces aren't that much, so the ions can move.
Okay, because when they're energetic, the ions can move around, the charged particles can move around. So SrCl2 has free moving ions. And why doesn't sulfur chloride conduct electricity? Because they never gain or lost electrons. There are no charged particles. SCl2 has no free moving electrons or ions. That's it. So covalent molecules, they never conduct electricity because they never have charges. Apart from the only one that conducts, there's one exception, that's graphite. But that's a giant covalent structure. Otherwise, covalent molecules, they never conduct electricity. So is this clear? Okay.
Yes, sir.
Let's continue again next time, okay? Tomorrow.
okay, sir. Allah Hafiz.
Okay, Allah Hafiz.
Allah Hafiz, sir.